a little bit about a map. A map is also another very common data structure. This is one that isn't used as often as it could be. A lot of people that are starting out learning Java don't really realize how often a map can really help them to solve a programming problem. So a map is a really nice collection. And a map is basically, it's like a dictionary. It has keys that are unique, and each key must be unique, just like a dictionary. A word is a key in the dictionary, and then the definition is a value. And a map just maps some key to a value. And the way you can think about this in Java is it maps some types together. So a key has a type and a value has a type. So if you're actually implementing a dictionary in Java, you might make a map that has a string for a key and a string for a value. And the key string might be the word, and the value string might be the definition of that word. So a map is just some way of connecting two pieces of data together. So now let's take a look at an example of using a map in Java. We're going to convert our list, our collection of pages that was a list, into a map, because we're going to want to now map a page number to a page. So in this example, we just had a bunch of pages in our list, but they didn't have any kind of page number. But we might want to be able to have our pages have a page number associated with them, or maybe even look up the pages by page number. So maybe we'd want to be able to pull page number 5 back. So the way that we're going to do this is we're basically going to change this, and I'll just comment this out so that we can see this here for reference. But we're going to change this to use a map, and this map is going to take two data types. One is the key and the second is the value. So in this case, we're going to use an integer as a key. And then for the value, we're going to use a page. So we're basically going to map a number to a page. And we have to use the object type. If you remember the boxing and unboxing here, we can't use the primitive type here because this collection requires an object. So we're going to map an integer to a page. And that integer is going to represent the page number, and the page is going to represent just the page the same as it did in the list. So we're going to call this pages map, and we're going to create a new hash map of type integer page. And I'll hit Control-Shift-O in Eclipse to auto import Java util map here and Java util hash map. And this is kind of a confusing syntax here. The map really confuses people a lot because they don't know what to put here, and this looks a little bit weird. But you just have to remember, with a map, you have a key and a value, and you need the type of the key and the type of the value. The type of the key in this case is an integer because it's going to be a page number, and the type of the value is going to be a page. And so we're going to map a number to a page. So let's see how we could do this. So in our print method here, we were adding pages. We're not going to do that anymore. Instead, we're going to put pages. That's the syntax we use for a map. And we're going to basically put a mapping into our dictionary or our map. So the way that we're going to do this is we're basically just going to call pages map dot put. And then you can see it's already kind of filled in the types for us. We need an integer for the key and a page for the value. So our integer here is going to be what the copy number is. So we need to figure out how to make a number that's going to represent the page number. Let's go ahead and make this really simple. So let's just declare an integer here called page number, and we'll set it to 0. And then when we get in here, we'll just increment the page number every time that we print a page. In fact, let's go ahead and even just start this at 1, since we're just going to start with page 1. So we'll basically, when we decrement the number of copies, we'll make the page number incremented by 1. And you could just calculate this from copies as well, but I think this makes it just a little bit more clear and easy for this example. So we're going to put whatever the page number is, and then for value, we need to create a new page, just like we did when we had a list. So I'm going to create a new page, and I'm going to put text to print But I'm going to do one other thing. I'm going to add to the text to print this colon, and then I'm going to put page number. And I'm just going to do this so that we can see that each line is mapping to the correct page number. So we're going to end up with whatever the text was plus a colon and then a page number. So using this, we are going to basically add entries to our map. They're going to map each page number to the page that it represents. Now, what we can do is go through and print out each page. I'm going to get rid of this output pages method, and we're going to create a new method called output page, and we're going to specify the page number. So I'm going to create this method, output page, and then we're going to say page number, and then we're just going to do system.out.println, and we're going to print from our map. So we're going to call page map dot, or rather pages map dot get, and then we're going to get based on the page number. So we're going to get page number, and then on that we're going to call get text. So this is a little bit complicated here for what we've done, but I want to kind of show you this is something that you'd commonly see in Java as a chaining of methods here. So we have our system.out.println, and inside here we have used our map, and we've called get on our map in order to get something out of the map. So we're getting out of the map based on our key. We pass in the key. The key is the page number. So in this map, it's going to get the value that corresponds to this page number. So we pass in page number 5, it's going to get page 5. And then on the page 5, so what this evaluates to, it's going to call get text. And that's going to give us our text. And then the result of that gets passed into our print line. We could have done this on separate lines, but this is a lot more concise here, and it's really not that complicated. So I would usually put this just all together on one line like we did here. So let's go ahead and take a look at how this would work. So we're doing our load paper, we're doing our print, and this time, remember, it's going to be storing up those pages in a map. And so now we can call output page, and we can choose our page number. So let's choose a page number 3 and run this and see what happens. Now you can see it printed my printer is on, and then our page number corresponds to 3 here, and we could do this same thing with 2, and you can see it's printing page number 2. So the basic idea behind a map is that you're just mapping two things. In this case, we're mapping a number to a page, and we've basically used this put method in order to put the entry into the map, and we put it based on the page number and then a page, our key and our value. And then to get them back out, we just basically called this get, and we passed in the key, which gave us back the value, which then we called get text on. And maps are really useful in a lot of ways when you want to be able to map two pieces of data together. If you think about it, without a map, it'd be really hard for us to figure out the page numbers or to map page numbers together, especially if you want to do something like replace the page number. And when you have a lot more complicated data structures, a map really makes it very useful to map two pieces of data together rather than trying to keep two lists that have the same index in that list in order to correspond to items. A set in Java is really based on the mathematical idea of a set. If you're familiar with that, then this will probably make a lot of sense to you just by saying that. If not, a good way to think about a set is just some unique grouping of things. And what I mean by unique is that you cannot have any duplicates. So a set of numbers is usually a good mathematical example. And you could think of a set of numbers as maybe if you had the numbers 1 through 10, there would be exactly 10 numbers in there. There couldn't be 11. You couldn't have one repeated twice. So a set really is just a yes or no. Every number that exists in the world either exists inside a set or doesn't exist inside that set, but you can't have that number exist more than once inside that set. So that kind of makes it different from a list. And of course, you have to be able to compare items that are in a set because you wouldn't know if they were unique or not. So they have to have some kind of way of comparing them. Another good example of a set would be fingerprints. If you think about it, the set of fingerprints, the FBI uses a big database of fingerprints because they're unique. So there's a set of fingerprints that exist in that database, and no two are exactly alike. So now let's take a look at a set in Java. And I'm going to show you a little bit more of a simple example for this one and also for the queue, since those aren't used quite as often. And we've really seen how to use collections in general in a real printer class. But I'm just going to demonstrate to you how a set works, and then you can really use that in a lot of different situations on your own once you understand the basics of how it works. So I've got our example here, and I'm not actually going to use our printer. I'm just going to delete this code here, and then we're just going to create a new set, and we're just going to store a set of integers. And I'm just going to demonstrate the basic usage of a set. So we can declare a set of integers here, and we'll call this my set. And then we'll create a new hash set is usually the default implementation that you're going to use for a set. You can, of course, use different implementations, and this should be integer. But hash set is probably one of the most commonly used implementations. And the set, you remember, has to have unique values. So if we do myset.add, we can add a 1. We can do myset.add. We'll add a 2. myset.add, we'll add a 3, and then we'll do myset.add, and we'll try to add a 1 again. Now what's going to happen here is it's not going to add the 1. So we can demonstrate this by calling a common method on collections called size. And so we can just do system.out.println, and we can print what the current size of this collection is. So we can do myset.size, and this is going to give us the size. And you can see here, if this were a list, it would have given us 4, but because it's a set, it's only going to give us 3 because they have to be unique. So I'll run this, and you can see we have a 3 that's output. So that's really the basic idea of a set. It's really simple. It's just a way of making sure that your items are unique. In fact, the big usage of a set in Java is really to get rid of duplicates. A lot of programmers will use a set or convert a list to a set just to get rid of the duplicates out of that list.